Hi, Alex here with the second part of a two-part video where I'll be showing you how to apply distributed member loads. For this video we'll be going over uniform member loads along with trapezoidal member loads and other varying member loads such as parabolics. If you didn't watch the first part I went over how to apply point loads and how to distribute them and organize them as well. If you haven't seen that, you can go back to our channel and find that under videos, playlist, and student tutorial videos. Okay, let's get started. Sometimes it can feel like a zoo when you're trying to figure out how to apply these uniform loads, so I'm going to get rid of this giraffe and get to our simple beam example. For this example, I will be doing 5 different distributed loads. So I'm going to create 5 different beams by simply highlighting my beam, controlling and clicking and dragging them, and this will copy anything you highlighted. For the first beam, we're going to go into our member loads, which you can do this by going to new member load using the button up here. The first one we're going to be doing is a uniform load, which is probably the simplest one, or is the simplest one, I'm sorry. For this one, we're just going to do a -1 kip per foot. This will be in the global Z direction. We do -1 because we want it to be a downforce and our global Z axis is pointing upwards. We'll click OK. And as you can see, we can select the beam we would like to apply this to graphically. For this next beam, I'll show you how to do a trapezoidal load. This is pretty simple. As you can see, the trapezoidal load graphic is up here. We have our P1, which is the starting force, and P2 is the ending force. Down here is where you can set those magnitudes. To start off, we'll just keep it at -1 and we'll end it with -3. Click OK. As you can see, I had the beam selected before I went into the dialog box, so clicking OK, it already knew which beam to apply it to, and you can see that our load was applied. The next beam we'll be going over how to apply a tapered load, which is kind of like a trapezoidal load, but with this you can pick at what locations on the beam you would like your peaks to be. For peak 1, we'll keep it as -1. Peak 2, we'll keep it as -3 kip per feet. And here you can see the distances away from the member start, A and B. You can pick that down here. For member A, for the first peak, we'll start that at 25%, and the second peak, we want it to peak at 75% away from the member start. We'll click OK. And as you can see, that didn't go the way we wanted it to, so we'll double click on our load. We'll check off relative distance. We'll enter 25% and then 75%. Click OK, and there we go. 25% away, it peaks 1 kip per foot. 75% away from the member start, it peaks 3 kip per foot. If you're wondering which direction or how do you know which is the member end and start, whenever you hover over a beam, you can see you have an arrow right here that'll tell you which direction you modeled the beam and which direction it's going. If you want to reverse this direction, you can simply right click on the beam, hit reverse member orientation, and now the orientation of your member was switched. I'll right click again, switch that back. For the next member load, I'm going to show you how to apply a parabolic loading, which is not linear unlike trapezoidal and tapered. This nonlinear load will be a curve, and you can see you can pick P1 and P2 for your beginning magnitudes and ending magnitudes. Our beginning magnitude will be -1 and our end magnitude will be -2. And you can see you can pick your peak magnitude, which we'll make that -3. We'll click OK, and as you can see, our parabolic loading was added to. Now for the last type of loading, I would like to show you how to apply a custom loading, which you can get very fancy with. We'll select our member, we'll go to member load, we'll click varying, and then next to varying you have this edit varying load button. This is where you'll define the loading you would like to apply. I'm going to highlight all of these settings, click delete. Just to keep it simple, we're going to define our load every 10%. So we'll start with 10, 20, 30, 40, and as you can see, when you click on a new cell, it already defines and knows the pattern you were looking for. You can also export and import to Excel for this type of loading if you really want to get detailed with it. Every 10% we'll start off with -1 kip, and we'll just increase that by 0.25 kip per feet every 10%. So we got -1, -1.25. We'll click OK, and now you can see our varying load was applied to our member. And we can always go double click on this load, go back in, edit varying load, and change any of that if we want. Now you can see that all our distributed loads, all the different types of distributed loads you can do, are displayed in our graphical area. Click Calculate All, and as you can see we have our global deformations for each of our members, along with our axial forces, shear in the Z and Y, moment in the Z and Y, along with any torsion. So I hope you found this video useful in clarifying the different distributed loads you can do. Again, if you missed the first video, I went over how to distribute point loads. That also has a lot of different settings you can play with, and thanks for watching.